So the other part of today's lesson is about making dilutions. So to make a dilution, which is what I do a lot when I'm preparing your labs, I'll take a concentrated acid molarity and dilute it to whatever molarity we might need for the lab. To do this, I simply set up an equivalence. One important factor to remember is this silly saying, acid to water, do as you oughter. Means that I need to make sure that I am not adding water to my concentrated acid solution, that I'm doing the other way around and I got to have the water I need and I'm adding the concentrated acid to it. Some dangerous things can occur if you do it in the opposite direction. If you add water to very concentrated hydrochloric acid, for example, you can get some chlorine gas coming off. So you always want to put your water in, add the acid, and then add a little more water to top off your dilution. So for this example, again, we're just taking the two concentrations and finding out the equivalence. Usually I will know how much I'll need for all the labs. Say I need 500 milliliters. I will know that I need 500 milliliters of, let's say, I need it to be a 1 molar solution. I'm also going to know what the stock solution is. Maybe I'm making it out of 6 molar solution. What I don't know is how much of that stock solution do I need to add to my 500 milliliter volumetric flask. So I will plug in the molarity of 1 that I need for the lab, the 500 milliliters that I'm making, and I will know that my stock solution is 6 molar, and then I'll solve for V1. Let's look at an example of this in the problems on the next page. So the first practice problem, this case I don't have 6 molar, but I have 12 molar concentration hydrochloric acid, and that's how we buy hydrochloric acid. The science teacher dilutes the acid for the labs. How would the science teacher make 2 liters of a 2.5 molar hydrochloric acid solution from this stock solution? So again, we know everything except for the amount of volume of the concentrated solution I need to add. So we're going to plug in all of our known numbers. We know that the M1 is 12 molar, the concentrated solution is 12 molar. I don't know how much of the 12 molar solution I need to use to make this, but I do know that I want my final solution to be 2.5 molar, and I must be using a tiny amount of just 2 liters here, which is 200 milliliters. So I need to calculate this. And in order to do that, I would multiply these two together, divide both sides by 12. I wind up with a volume of 0.417 liters. Know that that's 417 milliliters, but I'm going to take 0.417 liters of the stock solution, add it to some water, because remember, acid to water, do as you oughter. Then I'm going to add enough water into that volumetric flask to make the final volume 2 liters. Try number 2, where I want to know what the final concentration of a sugar solution if 300 milliliters of water is added to 500 milliliters of a 2.5 molar solution. Because these are equivalents, I can leave milliliters and milliliters in here instead of converting. I can also convert, but do remember that this number does have liters. The only reason that I can leave them in milliliters is because they are going to cancel one another out in this case. So again, this time I'm going to take 2.5 times 500, divide it by the 800, and I'm going to get a molarity of 1.56 moles. Please try some of these in worksheet number 2. Try some in your homework. Try to go back and do that bell work from this morning. Have a great day.